in my workplace at University of Debrecen, we successfully apply spatial bone substitution technique from several years. So in the next few minutes, after a short introduction and the outlining of the problem we have to solve, I would like to introduce you our equipment and the process step by step that we apply for bone substitution. So laboratory biomechanics is a part of a department of orthopedic surgery and has four main research areas: base research, medical device development, biomedical testing, and of course 3D printing. As a part of medical department, we use 3D printing for medical applications, of course, in the first place, such as modeling of difficult anatomical situations. We can see an ugly bone tumor around the hip joint in this picture. We use it also for preoperative planning, and we use 3D printing as a classical rapid prototyping application to build a 3D model of different medical devices. And the main area that we use 3D printing is the custom-made implants in the field of orthopedics and the field of cranioplasty. In this picture, we can see some steps of metatarsus replacement. We can see the implant here, but at the rest of my presentation, I would like to focus on cranioplasty implants. So, why do we have to use our technique to make custom implants? The main problem is that after serious head injuries or after brain surgeries, the remaining scar defect in a regular case will be filled by an in situ handmade implant. So the neurosurgeon make this implant by hand in the operation room, and the main problem is that this implant is never perfect, and sometimes it is far from to be good as well or satisfactory. So based on our earlier experiences and earlier cases, we can solve, I can state that we can solve this problem. So applying our technique, we can produce much better implants like by hand. Our equipment is the one of the key for this technique because it is a professional object connex 3D printer that can build the objects from two base materials. What's more, it can mix these materials into new materials called digital materials. And this device has a support material system as well that assures that there are no any geometrical limitations of the object we want to print. Okay, so now let's see the process itself. The first step is to get the 3D model of the skull. So we use CT scans to reconstruct the 3D model of the bones. So because of the CT machine itself can reconstruct the 3D model and it cannot export this, we have to use the images to reconstruct the 3D model by external software. So the CT can export these slices and important informations as well in the so-called DICOM format. So we use materialized mimics for the reconstruction of the defected skull. This is a professional software and has many functions beside the pure 3D reconstruction. For example, it can reduce the noise of the slices, as we can see here. After we have the 3D computer model of the defected skull, we have to design the implant, and we use some editing steps to get the shape of the implant. So we mirror the defected skull and we apply Boolean subtraction to get the shape of the implant, and we can see the result in this case. So this was the original, and we can see the implant model in green here. Okay, so after we have the models in computer, we print it by the 3D printer. We print both the implant model and the skull also, because we check if the implant fits in real. So it's not question anymore, but you can check it yourself. Because of this material cannot be implanted, we use some molding steps to get the final implant. We mold the 3D printed model of the replacement of the substitution, and after we remove the model, the master model from the silicon, we get a cave inside the silicon with the same shape as the implant model. So in the final step, this silicon will be sterilized, and in the operation room, bone cement will be casted into this cave, and this bone cement will have the same shape as the master model in the first step. Actually, it is not operation room picture. It was taken on a laboratory. So we get the implant in the operation room, and the last step is the implantation itself. So we can summarize the process here. After CT scans, we reconstruct the 3D model, and after we have the 3D model of the implant, we print it, we mold it with silicone. After we remove the master model from the silicone, it will be a cave with the same shape, and we cast it with the same bone cement that is used for the handmade implants, and finally it will be implanted. We have about 30 cases with this technique, from the simplest one to such complicated cases like this. In this case, we had to design an implant that will be implanted beside another implant. Here we can see a model of metal implant. This is a titanium implant here that will be remain at the same place. So we have had to design it in this environment. And by the way, we can see, but the symmetry was so it was absolutely asymmetric. And another case when we had to remove these implants and this bone piece digitally. So we had to do this by software, and we can see the result here. This is the 3D printed defect, and the defect with the replacement. So thank you very much, and so thank you for your attention. What is the composition? PMMA, so polymethyl methacrylate. This is regularly used for implantation. For example, the orthopedic surgeons use it to fix the hip prosthesis or knee prosthesis.
So it's acrylic, right? Polymethyl acrylic.
Yeah.